Good evening, dear students. Today I am going to discuss some revision questions of basic concepts of chemistry, and our first question is based on mole concept. Okay. How many moles of atoms are present in 6 grams of carbon? Okay, I think this is one of the simplest question of mole concept. We know that number of moles N is equal to W by M. As you know, W is the given mass of the substance and M is the molar mass of substance. So here, given mass of carbon, that is W is equal to 6 grams, and molar mass, as you know, molar mass of carbon is equal to 12 gram per mole. 12 gram per mole. Now number of moles N is equal to W by M. This formula using is equal to 6 grams divided by 12 gram per mole, that is 0.5 mole. This is the answer. Okay. N is the number of moles of the substance, that is here carbon, and W is given mass of carbon, that is 6 gram, and M is the molar mass of carbon. Then in the question 2, we have to calculate the number of atoms in a given sample of compound. Calculate the number of atoms in 1.8 gram of water. Okay. So here given mass W is equal to 1.8 gram, and molar mass of water, it is 18 gram per mole. Okay. Given mass is 1.8 gram, molar mass is 18 gram per mole. How 18 gram per mole? You know this because H2O contains 2 atoms of hydrogen. 1 atom of hydrogen 1 U, mass of 1 hydrogen atom 1 U or 1 mu into 2 plus oxygen 16 U, that is 18 U or mu. This is the molecular mass, but when it is asked to write the molar mass of water, it is 18 gram per mole. That means the mass of 1 mole of water is 18 gram. So now we have to calculate the number of moles of water molecules. Okay. Now number of moles of H2O molecules, N is equal to W by M, that is 1.8 gram divided by 18 gram per mole, 0.1 mole. That means in 1.8 gram of water there are 0.1 mole molecules. Okay. Next, we have to calculate the number of atoms. One H2O molecule contains 3 atoms, 2 atoms of hydrogen and 1 atom of oxygen. That's why in one H2O molecule there are 3 atoms. Like this, in 1 mole H2O molecules, the number of atoms is equal to 3 moles. Okay, 1 molecule contains 3 atoms. Like this, 1 mole H2O molecule will contain 3 moles of atoms. 3 mole atoms. Like this, 0.1 mole H2O molecules contain 0.1 into 3, that is 0.3 moles. Okay, you can convert this into number if it is equal, if it is asked. That means 1 mole is 6.02 to 10 to 23, 0.3 into value of 1 mole, 6.022 into 10 to the power 23. Okay, so you can multiply with this 6.022 into 3, 660, 18, that is 1.8066 into 10 to the power 23. So this much atoms are present in 0.1 mole H2O molecules. So the answer is 1.8066 into 10 to 23 atoms. Okay. Next one, the type 3. That means if it is equal to calculate number of electrons in a given mass of compound, how can you calculate? Question 3. How many electrons are present in 1800 grams of water? Okay. First we have to calculate how many H2O molecules are there in 1800 grams of water. So here given mass is 1800 grams and molar mass of H2O, you already know this is 18 gram per mole, and number of moles of water molecules or H2O molecules, N is equal to W by M, that is equal to 1800 gram by 18 gram per mole, that gives 100 moles. Okay. So in 1800 grams of water, 100 moles of water molecules are present. Okay. Now you have to calculate how many electrons present in one water molecule. The number of electrons present in one H2O molecule is equal to 10. How 10? Just to think of the number of electrons in individual atoms. One hydrogen atom contains one electron, because you know the atomic number of hydrogen is 1. So two hydrogen atoms contain 2 electrons, and atomic number of oxygen is 8. That means in one oxygen atom there are 8 electrons. So two hydrogen atoms contain 2 electrons plus 8 electrons of one oxygen atom, that gives 10 electrons. Okay. So one H2O molecule contains 10 electrons, and this way we can write 1 mole H2O molecules contain 10 mole electrons. Okay. One H2O molecule contain 10 electrons, like this. 1 mole H2O molecules contain 10 mole electrons. This is the simple unitary method. Like this, 100 mole H2O molecules contain 10 into 100, that is 1000 mole electrons. I think this one is visible. One H2O molecule contains 10 electrons, so 1 mole H2O molecule will contain 10 mole electron. Like this, 100 moles of water molecules will contain 10 into 100, that is 1000 mole electrons. Okay. You can convert this into number, that is 1000 into value of 1 mole. The next page we can write it. So 100 mole H2O molecules contain 1000 mole electrons, or 1000 into 6.022 into 10 to the power 23 electrons. Okay, that is 6.022 into 10 to the power 26 electrons. This is the final answer. Okay. So in the first question, mass of one element is given. Here element is carbon, and we have to calculate the number of atoms. 6 grams of carbon. In 6 grams of carbon, how many atoms are present? Okay. So here N is equal to W by M. N is the number of moles, and W is the given mass, M is the molar mass. Like this, we can put the values. 6 gram by 12 gram per mole. 12 gram per mole is the molar mass of carbon, so it gives 0.5 moles. This is a very simple question. The next question, we have to calculate the number of atoms. So type 2 question. If mass of one compound is given, then we can calculate how many atoms are present in the given mass of the compound. And in the third type question, we have to calculate the number of electrons. Okay. Here 18 grams of water given, and first we have to calculate how many water molecules are present. Then in one water molecule there are 10 electrons, as I have explained earlier. In 1 H2 molecule 10 electrons, in 1 mole there are 10 mole electrons, and in 100 mole of H2 molecules there are 10 into 100, that is 1000 mole electrons, and then we convert it into number. Okay, so this was about particle counting, means number of atoms, molecules or electrons. The next concept in question 4 is to calculate mole fraction. This is regarding mole fraction. Calculate the mole fraction of sodium hydroxide NaOH in a solution prepared by dissolving 20 grams of sodium hydroxide in 180 grams of water. Okay. So here solute is sodium hydroxide and solvent is water. First we have to calculate the number of moles of individual components. So number of moles of sodium hydroxide N2 is equal to W2 by M2. For solute I am using N2, for solvent I am using N1. So here given mass of sodium hydroxide, the solute here is 20 grams, and the molar mass of sodium hydroxide is 40 gram per mole. Why 40 gram per mole? As you can see, Na atomic mass 23, oxygen 16, hydrogen 1. If you add, that gives 40 U. The molecular mass is 40 U or AMU, and the molar mass will be 40 gram per mole. Let me show you this calculation again. Sodium 23 U, oxygen 16 U, hydrogen 1 U. If you add this, that gives you 40 U or AMU. This is the mass of one molecule of NaOH, but if you consider molar mass, that is 40 gram per mole. So this gives 0.5 mole. Okay, so you have calculated the number of moles of sodium hydroxide taken. Like this, we can calculate number of moles of water. That is N1 is equal to W1 by M1. Okay. So here given mass of water is 180 gram and molar mass, as you know, 18 gram per mole. That gives 10 moles. Okay. And the mole fraction of NaOH or the solutes is given by X2 is equal to N2 by N1 plus N2. So N2 is 0.5 mole, N1 is 10 plus N2 0.5. Okay. So this gives the mole fraction of sodium hydroxide is 0.5 by 10.5. Okay. You can simplify this, or you can write 1 by 20 gram. Okay. You can also convert it to decimals. If it is asked to calculate the mole fraction of water, then we can separate it from 1. Okay, so I will be explaining one more question regarding this. So first you see, in this question, mass of solute is given, that is sodium hydroxide. Mass of sodium hydroxide is 20 grams given here, and mass of water is 180 grams. Okay, so we have calculated the number of moles present in 20 grams of sodium hydroxide and in 180 gram of water. Okay. Then the final formula is x2 is equal to n2 by n1 plus n2. n2 is 0.5 mole, n1 is 10 mole. Okay, as we have copied here. Next one, question number 5, same concept regarding mole fraction. Calculate the mole fraction of calcium oxide or hydroxide, calcium hydroxide in a solution prepared by dissolving 2 moles of calcium hydroxide in 50 moles of water. Here the number of moles of individual components like calcium hydroxide and water is given, so directly we can put the formula here. Number of moles of calcium hydroxide is equal to 2 moles, that is N2 is given. Again, number of moles of water, that is N1 is equal to 50 moles. So we have to calculate the mole fraction of calcium hydroxide. Now mole fraction of calcium hydroxide is given by x2 is equal to n2 by n1 plus n2, that is 2 by 50 plus 2, that is 2 by 52. Okay, that is 1 by 26. Suppose in the same question we are asked to calculate mole fraction of water. Now mole fraction of water x1 is equal to 1 minus x2. This is because sum of mole fractions of all the components in a mixture or solution is equal to 1. So it is a binary solution containing two components, x1 plus x2 is equal to 1. That's why x1 is equal to 1 minus x2. Okay. So we can put the value of x2 here, 1 minus 1 by 26. That gives 25 by 26. We can convert this into decimals. Next class we will be discussing molarity, molality, normality, and some more numericals based upon those concepts. Okay. So for today, only these 5 questions. All of you try to see the questions again and again and their solutions also, so that you can understand clearly. Thank you.